will be f of x2. Perfect. So how do I determine the average rate of change of the function between these 2 points a and b? The average rate of change between a and b is a ratio of rise over run. So if I draw this line between these 2 points, it's the slope of this line. The slope of this line, AB, or the average rate of change, they are the same. y2 minus y1 over x2 minus x1. Rise over run. That is what we call the average rate of change. And we're going to come back to that. Based on this, I want to talk about one concept, and then we'll come back to our function. That concept is difference quotient. We needed this first. You'll see in a moment why. Okay. Back to our same graph. Here it is. Same graph. F of x. But this time, this will be P and Q. The coordinate, the x coordinate of P will be x. And the x coordinate of Q will be x plus a little bit. And you can say this is not a little bit. Assume that I zoomed in so I can explain. This is little h. H is small. A little bit. Small. P and Q are very close to each other. Again, I'm going to ask you to give me the y coordinates of P and Q. What will you say about the y coordinate of P? Anyone?
F of x1.
But this time we have f of x. Good. And the y coordinate of Q?
F of x plus h.
Very good. The reason I'm doing this now and early is because I want you to understand that f of x plus h does not mean f of x plus f of h. So please be very careful. It means the function value for this x value. Okay, the difference quotient is the average rate of change of this function between P and Q. Can anyone give us the difference quotient? And moving forward, we have to memorize it. Can anyone give us the average rate of change or the difference quotient? Anyone? Sorry, I muted everyone so there is no noise in the background, but please unmute yourselves and every time you speak.
Will it be f of x plus f of x plus h?
Careful. So it's not plus, but it's f of x plus h. F of x plus h does not mean f of x plus f of h. It's just one value, f of x plus h. And then?
Minus.
Very good.
F x second.
F of x. Very good. Over.
X
It has to be the corresponding. So this is f of x2 minus f of x1 over x2 minus x1. It has to be in the same order, minus x. It happens that these two go away. So the difference quotient moving forward for any function is this. What does it represent? Not only the average rate of change between P and Q, but since P and Q are close to each other, this will represent almost the slope of the tangent line at P, also almost the instantaneous rate of change at P, of the function at P. Almost. I stress on the word almost. Almost the rate of change, the instantaneous. The instantaneous rate of change at P. Almost. We're going to get to that later. Okay, what's all this all about? You will see in the next chapters. But at this point in time, we are asked to find the difference quotient for different functions. So give me a quadratic function, any quadratic function you can think of, so we can find the difference quotient for it. Any quadratic function. So the slope of the tangent line at P, you're going to see that later because this is the rate of change, but since Q is very close to P, is almost the slope of the tangent line here. And almost the instantaneous rate of change at P. Okay, can anyone give us a quadratic function? Any? Okay, I'm going to look at 2x squared minus 3x plus 1. And let's say we're asked to find the difference quotient, which moving forward we have to remember it by heart. It's f of x plus h minus f of x divided by h. And we are asked to calculate it. Find the difference quotient for f of x, this one, and simplify it fully. It fully. Okay, this piece is very clear. There is nothing I can do to this. This piece is very clear. It's this one. I would just have to replace it in here and distribute -1 to all three terms. But the only thing I don't have is this. Okay, so let's determine it. Good. Remember the pattern. 2 times whatever minus 3 times whatever. So 2, the whatever is x plus h, minus 3 times whatever plus 1. And coming back, that's why I did this and this and this. So now I have the answer to this piece. First term squared, last term squared, and the middle term is 2 times the product. I will close the parenthesis. I'll distribute here. Only now I'm allowed to distribute 2. 2x squared plus 6xh plus 2h squared minus 3x minus 3h and plus 1. And now finally I have this piece as well. I'm ready to put all of them together, but at first a note.
Where'd you get the 6xh?
I'm sorry. No reason. Thank you. No, I wasn't trying to see whether somebody's paying attention. No. I was just thinking ahead, and in my mind, 2 times 2 was 6 instead of 4. No excuse. I wouldn't even say anything. Note, 2 things have to happen when we calculate the difference quotient. For the difference quotient, 2 things have to happen. All terms without h from the numerator must cancel out. All of them. Otherwise I have an error. The second thing that is mandatory that has to happen, h from the denominator must simplify. Must go away, in other words. Otherwise, I'm doing something wrong with the difference quotient. So for a difference quotient for any function, 2 things have to happen. All terms without h must go away from the numerator, and h in the denominator must go away. I'm not saying that h will completely disappear from the final form. I'm not saying that. I'm only saying that the terms without h from the top must go away, and the h from the denominator must go away. But the final form of the difference quotient may still have h in it. Okay, and we're ready now, I think, to finish it up. So then the difference quotient for this function. Watch me run out of room, I always do. So I copy f of x plus h, which is all this, simplified. All this is this. So I'm copying it. 2x squared plus 4xh plus 2h squared minus 3x minus 3h and plus 1. So I only copied this. Now I have a minus that has to be distributed to negative. It's going to be negative 2x squared plus 3x minus 1. Negative 2x squared plus 3x minus 1. And everything divided by h. If terms without h, maybe some terms with h go away too. That's a bonus. That's nice. But at least the terms without h must go away. Let's see. Negative 2x squared with positive 2x squared, gone. Negative 3x with positive 3x, gone. Positive 1 with negative 1, gone. So the first note, the first condition is fulfilled. All terms without h from the numerator did cancel out. Now, I see there are 3 remaining terms. They all have a common factor. Which common factor? And that I need to pull out, in other words.
Going to be 2h and negative 3.
Just h. h in all 3 terms. So the first one left is 4x. From the second term we have plus 2h. From the last term we have negative 3. And here is how the second condition is fulfilled. h from the denominator must simplify. And it will. Here it is, gone. The simplified form of the difference quotient for this function is this. And as I mentioned, it may still have h in it, and it will have h in it. So for Thursday, please finish up R.1 homework in my lab math and come back with any questions that you may have. We touched up on every type of problem that you have in